Hello, my name is Camryn Kendrick, and today I will be your teacher. Today we will be solving this problem. f of x equals a log base of 3, x plus 3, and we are asked to find 3 points and label them on a graph. To start, I am going to set up 3 different equations, making sure 2 of them equal 0 and 1, and for the last one, you could choose any point. I chose 2. Next, I'm going to turn this from log form into exponential form. Then you are going to solve for x. Now plot x as a point. And in this case, f of x equals y. Then repeat for the other 2 equations. Now that I have all my points, I can put them on the graph. Now I have found and labeled 3 points, completing part A. Part B asks us to find and label the asymptote. An asymptote is the vertical line that the curve approaches but never meets. To find the asymptote, you could take the opposite of what's in the parentheses or just solve for 0. For this equation, the asymptote is x equals -3. Now we're going to label this on the graph using a vertical line. The vertical line is going to be where -3 is on the x-axis. Next, we're going to find the domain and range, part C and D. To find domain, we'll use the graph from left to right. The farthest point to the left is where the asymptote is at -3. And then the curve continues on to infinity to the right, using parentheses for both points. Now, to find range, we look at the graph from bottom to top. The curve is going down on the negative side, making it negative in infinity. Although it looks like the curve isn't going up, it is only slightly on infinity. A range of negative infinity to infinity is also known as all real numbers. For this next problem, we will be expanding and simplifying this log. When expanding logs, there are 2 rules to follow by. When there is division, you can expand it out with subtraction. And when there is multiplication, you can expand it out with addition. Whenever there is just log, you can assume that the base is just 10. So now I am going to put log of base 10 and use the subtraction method as that in the parentheses it is division. Now I'm going to expand them even more. Looking at this parentheses, we see that y is multiplied by square root over x, so we can use the addition method, making sure that you put the log in front of each parentheses. After doing that, I'm going to carry over the minus, and then repeat with the 10 to the power of 2 multiplied by z. Now I'm going to use a method called the power rule. This is moving exponents to the front. Since this 10 had an exponent of 2, we're going to move it in front of the log. And once I've rewritten it, this is the fully expanded version of this problem. And now to simplify it, I am going to distribute this negative and also combine the y and the square root of x. Once I have that written, I am going to condense this and use the subtraction as division, going in reverse. Making sure to include the -2, this is the simplified version for this problem. For our final problem, we will have to solve and check this equation. We are going to start by condensing this equation using the following rules we used for the previous problem, but going in reverse. So when we see subtraction, we are going to put it in division form, and when we see addition, we are going to put it in multiplication form. Putting the same log in front, we are going to put 3x plus 3 divided by 2. And on the other side of the equal sign, we will do x multiplied by x minus 1. Since these logs have the same base, they could be canceled out, and we can bring down what's in the parentheses. Now we are going to want to get this in A, B, C form. By first distributing, I am going to now multiply both sides by 2 to get rid of the 2. Now I'm going to set this equation to 0 so I can factor. Here I am going to subtract 3 on both sides. Then subtracting 3x on the other side. This is my equation once it's set to 0. Now that my equation is perfect to factor, I will begin to factor, multiplying the a and the c, which I get -6, and then I have to find two numbers that multiply into -6, but add to -5, and those numbers are -6 and 1. Now I rewrite this equation using those two numbers as x's, and then grouping this equation, and then factoring as usual. After factoring, I got an answer of two x's, -1/2 and 3. Now we are going to plug in these x's in the parentheses logs, but there's a rule that it cannot be a negative or a 0. So I'm going to plug in -1/2 first. As I plug in -1/2, I get -1.5 plus 3, which equals 1.5, which is a positive, so it works. There is nothing to plug in for the second log, so it works. But when plugging in x for the third log, it does not work as that it is a negative. This means we can eliminate a -1/2 as that it is not compatible. And now we do the same process for 3. None of them turned out to be negatives or 0, making 3 work. Now that we know that 3 works, we can plug it back into the equation. As we plug in 3 in for x, we are checking it to see if this statement is true. After solving and simplifying, we can tell that this statement is true. And so we have completed the problem. We have finished all the problems, and I hope I have been an excellent teacher. Thank you. Bye.